This tutorial is split into two parts. The first one covers the usage of HeadRoom Application. The second part shows how to use the HeadRoom node inside Spark to create a virtual reality project. HeadRoom is a real-time space tracking application and uses the original Kinect to track an observer's head in space. The advantage of using a stereo camera like the Kinect is the ability to track without the usage of markers. So an observer can just walk to an installation and the application starts to send transformation data. You can find the most current version of this application under github.com/techartlab/headroom. By clicking on releases, you can download the appropriate application for your system. It is based on open frameworks and is open source. Now I just downloaded the latest version of HeadRoom. Inside the folder I see the HeadRoom application and a data folder. Inside the data folder the setting files are going to be stored. At the moment it's empty. The next thing is I'm going to start up HeadRoom and I have a Kinect attached to it. I'm presented with the interface. On the right hand side the GUI, on the left hand side the help menu, and when I press V I can see 6 viewports. Number 1 shows me the depth image from the Kinect, number 2 shows me the video image, 3, 4 and 5 are being covered later, and 6 is the 3D view. I can navigate with the mouse and the left, right and middle mouse button. If I press P, it shows me the point cloud. At the moment you see the Kinect is still located at the center of the world. We're going to change that, but first we have to do the corrections, which are on the right hand side, top left right hand side. For this I place a double meter in front of me. You can see it when I switch over to number 2. See in the video how this double meter is in front of me. It's actually just 1 meter. And what I do now is I set the calibration point A and B to the left and the right hand side, and then I can press K, which is starting the calibration, and I'm pressing R to see the calibration results. I can see now the distance between A and B is 1324 millimeters. This is fairly far away, far off what I would expect, because it's exactly 1 meter, and I can see now that calibration point A is actually pointing at the wrong place. I have to shift it a bit. The video image and the depth image are not always perfectly aligned to each other, so I place those 2 calibration points A and B, and now if I press K again, I see now I get a bit better value, 924 millimeters, which is still not really close to what I would expect. So I keep on adjusting the calibration points a bit more closer to what it's supposed to be. I switch between 3D depth view and video view to make sure that the calibration points are on a spot where the depth view actually can detect the depth, the distance. And now I adjust the pixel factor and keep on pressing K, and when I raise the pixel factor you can see that the distance from A to B is actually more accurate now. It's now 1023 millimeters. I also have a distance, the distance measured from B to the Kinect, which is 1410 millimeters, and we can see distance to B is actually quite accurate now. The distance from A to B is quite accurate too, so I leave it with this, and I'm quite happy with this correction. So the next thing is I'm calibrating the reference plane. I'm putting away the measurement stick. And now I use the calibration points again and place them onto the plane that represent my measurement reference. So I choose the floor in my background. I place A onto the ground, B and C. I try to make as big as a triangle as possible. And then I press K. I just have to make sure that I'm avoiding the noisy bits on the floor. And when I switch over to view 6, I can see now everything has been transformed in a way that the ground is now really on the same plane as the reference space. I can see that HeadRoom has measured the accurate height on 2124 millimeters above ground. And I can see now myself nicely oriented in space. What I have to do now is adjust the sensor box, left, right, front, back, top and bottom. I have to make sure that those values are accurate, that everything that's inside the sensor box should be grayed out. So I can see now how a pink column starts to appear. So that means the tracking part is actually detecting my head. We can see now on the left hand side with view 3 how my head starts to appear. So I keep adjusting the sensor box until it suits my needs, until it defines the space I expect my head to be inside. Now I switch to view 3. In view 3 I see the depth image in an orthogonal view from top down. The lighter the pixels are, the higher they are. What I can see now is actually my frame rate is quite low, partly because of the video capturing, but also because I use a very high grain. If I actually, the number indicates the steps between the depth pixels. So I raise the grain in order to make sure that I have less points to calculate, and I adjust the grain size. I also have to adjust the blob values, the area min and area max. These are indicating how much surface a blob should have that is accepted by HeadRoom. It takes a bit of fiddling around until you get the right areas that are suitable for the setup you're choosing. The pink spot shows where HeadRoom actually detecting the top of the head. The light blue one is the center of the head, and the dark blue is its assumed position of the eye. Now this is not accurate yet because the gaze point is not the right spot. You can see it's on the same level as the top sensor box. And what I'm going to do now is I'm using the depth view and using the G key to tell where the gaze point is actually supposed to be. In my case, I want to have it in the center of my screen. So I use my fingers because the screen is not reflecting any infrared information to the depth camera, and press G and the mouse to tell where the gaze point is supposed to be. And I use K to calibrate again. And now I can see that the gaze point is accurate. Still, I can't see the screen in the point cloud. I just accidentally double click the mouse, which is resetting the mouse transformations. And now I can see how my eyes are more accurate assumed by HeadRoom. I'm still not happy with the eye level. So what I'm going to do now is I'm going to adjust the eye level. I'm using my hand, and I raise my hand the same level as my eyes. Just have to make sure that the blobs can actually detect the larger blob size that is going to happen now. And I adjust the eye level to the level of my hand. So I have to be upright and straight in order to make sure that this is accurate. And now the eyes are fairly accurate where I actually expect them to be. I can adjust also the eye inset, but I leave it with 0.7. Now what I also observe is that the whole thing is still quite noisy, and I actually have a noise reduction factor which allows me to raise the samples, and by raising the samples the noise is reduced. Unfortunately also the latencies are increased, so you have to find the right amount of samples versus latency that is suitable for your own project. I'm settling with 6. I think it looks fine now. And now pressing S will actually save all the settings. Once you press S and save the settings, we can have a look at the Finder, and in here we see all those XML files which store all the different kind of settings of the different kind of menus. And now I can switch off the point cloud, press V, and this view is actually the standard view, default view, which is the fastest one, which requires the least calculation time. I stop HeadRoom and restart it again, and we will see it actually has stored all the settings accurately. The last thing we want to do is we adjust the broadcast address. The broadcast address is the address we want to send our broadcast and tell the world that HeadRoom is in a network. And I'm quickly have a look at the network settings. And here I see my IP address, my local IP address. I'm actually in a network that has a classical 192.168.1.x IP mask. So what I'm going to do is I'm entering the broadcast IP address of the network, which is 255 at the end. This actually sends a broadcast information to all machines that are connected inside of this LAN on the port 47,500. The listening port is my local IP address and an individual port. I also stream all the body blobs and so on. And once that is done, I press S and open it again. And now HeadRoom is actually ready for being used by another application like Spark.